All right, so we're going to go with the third way to solve quadratic formulas and to solve quadratic equations. So the first way was using the square root method. The second way was by factoring, and then the third way is going to be using the quadratic formula. I want you to pause me real quick, and I just want you to read through all of this real fast, and then once you're done, unpause me. Quadratic formula can actually be used for any type of quadratic. So it could be used on the ones that you would typically do the square root, the ones that you would typically factor. However, if you can use the square root method and if you can factor it, those forms or those methods are a lot faster than this method, and I would want for you to be able to recognize when you could use those two forms and actually use those two forms versus using the quadratic formula. Essentially what you're doing is you're plugging your A, your B, and your C from, remember I talked about this last time, from that into this quadratic formula. The quadratic formula is negative b plus or minus big square root symbol b squared minus 4ac all over 2a. So this you'll need to memorize. Okay? All right, we are actually just going to start into the problems. So we're going to look at some examples and we're going to solve this one step by step by step. So first, here's my equation, 12x squared plus 7x equals 12. What you should notice right now is that we have an x and an x squared. Therefore, I can't use the square root method. I can only use the square root method if there's only an x squared and no x. What I would need to do, though, is get it into this ax squared plus bx plus c equals 0 form, so I need it equal to 0. So in order to do that, I subtract 12 from both sides. So I get 12x squared plus 7x minus 12 equals 0. So now that I have it in that form, I need to decide what the a, the b, and the c are. A is 12 here. B is 7, and C is negative 12. Then what I'm going to do is I'm going to plug it into the quadratic formula, which is negative b plus or minus big square root b squared minus 4ac all over 2a. Okay? So once I do that, I get negative b, so negative 7 plus or minus square root b squared, so 7 squared minus 4 times a, in this case a is 12, times c, which is negative 12. All that over 2a. And then we're going to start simplifying this. So I get negative 7 plus or minus 7 squared is 49. Oops, that should not be for 2a. It should be 2 times 12 because I'm plugging in 12 for a. Sorry about that. Then I'm going to do negative 12 times negative 4. So I'm going to grab my calculator. So 12 times negative 12 times 4. Those two negatives make it positive, so it's plus 576, all over 2 times 12, which is 24. 49 plus 576 is 625. So what I'm really doing is negative 7 plus or minus square root of 625 all over 24. Next step, so essentially I'm doing order of operations. Next step is I have to take the square root of 625. Sometimes it's going to be a whole number, sometimes it's going to be a decimal. If it's a decimal, read your question first to decide whether it wants it to the nearest tenth or hundredth. In this case, I get a whole number of 25. So I get negative 7 plus or minus 25 all over 24. I get two solutions because I have a plus and a minus. What that means is I do negative 7 plus 25 over 24, and then I do negative 7 minus 25 over 24. So negative 7 plus 25 is negative 18. Negative 18 over 24. 6 goes into both, so that's a negative 18 over a positive 24. So that's a negative number. 6 goes into 18 3 times. 6 goes into 24 4 times, so it's negative 3/4. Negative 7 minus 25 is negative 32 over 24. 8 goes into both. It's still going to be negative. Oh, I'm sorry, guys. Negative 7 plus 25 is a positive 18, so this is a positive 3/4. My fault. Sorry about that. This is why I need you guys here sometimes, because then you can tell me if I'm wrong or not. Okay, so 8 goes into 32 4 times. 8 goes into 24 3 times. So my two answers are 3/4 and negative 4/3. There is no way that I could have gotten those answers from factoring, because when factoring, you're looking for factor pairs, whole numbers that multiply. So that would not have worked. Those are my two answers. Leftmost answer would be this guy. Rightmost answer would be this guy. All right, let's do number 1 together. I'm going to add 12 to both sides. So I'm going to rewrite this. Negative 4x squared minus 9x plus 12 equals 0. My A is negative 4, my B is negative 9, and my C is 12. So now I'm going to plug it into that quadratic formula, which is I have written up here. So if you need to write that down below, go ahead and pause me, write it down here so you can see it. So negative B. This one's a little trickier. I'm going to do negative 9. Well, 2 negatives make a positive. Okay? Plus or minus big square root, negative 9 squared minus 4 times A times C. All over 2 times A, which is negative 4. All right. Now I have 9 plus or minus big square root symbol, negative 9 squared. Now, if you are plugging this into the calculator and you do negative 9 squared, you will most likely get negative 81, and that is incorrect. And it's not incorrect because the calculator is incorrect. It's incorrect because you did not enter it correctly. What the calculator is doing is it is squaring 9 and throwing the negative sign on. But what you really want to do is you want to take negative 9 and multiply it by itself. So you really want to do negative 9 times negative 9. So that number will never be a negative number because you're always squaring either a positive or negative number. So it will always be positive. Really, negative 9 squared you should be able to do in your head because 9 times 9 is 81. Then negative 4 times negative 4 is a positive 16, and 16 times 12 gives me a positive 192. All that's over 2 times negative 4, which is negative 8. 81 plus 192, 273. So 9 plus or minus square root of 273 all over negative 8. Square root of 273. 9 plus or minus 16.5. I'm going to round it to the nearest tenth. All over negative 8. Now, you have to do both your ways. You have to do 9 plus 16.5 over negative 8 and 9 minus 16.5 over negative 8. All right, 9 plus 16.5 divided by negative 8 gives me a negative 3.2 if I'm rounding into the nearest tenth. 9 minus 16.5, enter, divided by negative 8, gives me a positive 0.9, negative 0.9, if I'm rounding to the nearest tenth. We don't have a lot of room. These do take up more room, but you can see how these take a little bit more time than the other two methods. That's why if you can do the other two methods, please use those. Okay, next one. I'm going to subtract 8x from both sides. And I need to do x squared minus 8x plus 25 equals 0. All right, my a value is 1. So there's no number, we can't see the number in front of the x squared, which means that we have the invisible 1. My b value is negative 8, and my c value is 25. Let's see all those. Yeah, okay. So negative b, so negative negative 8, which makes a positive 8, plus or minus big square root, b squared minus 4 times a times c, all over 2 times a. You would have to put in the correct a value, though. Greg, why not? That's my a value, 1. Okay, let's simplify this. I get 8 plus or minus negative 8 squared is 64. Negative 4 times 1 is negative 4. Negative 4 times 25 is negative 100. All over 2. 64 minus 100, 8 plus or minus negative 36, all over 2. Everyone, for me, I want you to put in square root of negative 36. I get a domain error. The reason is because you cannot actually take the square root of a negative number, because there is no two numbers when multiplied, the exact same two numbers when multiplied, that would give you a negative number. You either multiply a negative times a negative and get a positive, or a positive times a positive and get a positive. So we're not going to get negative 36. So this means that there is no real solution. Meaning, if I were to graph this, I'm going to do that up here, it doesn't actually intersect the x-axis. It's above the x-axis going up, or it's below the x-axis going down. So no real solution. In Schoology, it'll tell you exactly how to put that in, but you most likely put no real solution into both boxes or NA, something like that. Okay, on this one, I'm going to add 6x to both sides, so I get 6x squared plus 6x, and then I'm going to subtract 9. That equals 0. A is 6, B is 6, and C is negative 9. All right, so negative B, so negative 6 plus or minus big square root B squared, 6 squared minus 4 times A times C. Sorry, guys. All that over 2 times A, which is 2 times 6. Okay, so if I reduce this, negative 6 plus or minus big square root, 36. Negative 4 times 6 is negative 24. Negative 24 times negative 9 is negative 216. All that over 12. And that is a positive 216 because I had a negative 4 times a negative 9 times a positive 6. All right, so now I'm going to start reducing that. I get negative 6 plus or minus square root 36 plus 216, which is 252, over 12. Square root of 252, 15.9. So I'm doing negative 6 plus or minus 15.9, all that over 12. So negative 6 plus 15.9 over 12. Negative 6 minus 15.9 over 12. So negative 6 plus 15.9, enter, divide by 12, enter. I get 0.8 is one answer. Negative 6 minus 15.9, enter, divide by 12, enter. And then I get negative 1.8. So those are my two answers on that guy. Go ahead and pause me. I want you to try number 4 on your own. I'm going to pause myself. I'm going to complete the problem, and then once you're done, unpause me, and then I will go over it with you. Okay, so here is number 4 in the bluish teal kind of color. First thing I had to do is I had to move over the 9, so I subtracted it from both sides. I wrote down my A, my B, and my C, and then I went ahead and plugged them in. When I plugged them in, it reduced down to 64, negative 108 under the radical. When I do 64 minus 108, I get negative 44, but I cannot take the square root of that negative number, so we have no real solutions on that. So next, in the next video, I'm going to go over a couple of these problems, and then that's what you're going to have your annotating homework on. If you notice, that is the last sheet of the packet. So we will have a short quiz over this, everything in the packet, the radicals and the solving the quadratics after that. And then we're going to go into our normal geometry unit 1 work. All right, guys, thanks.